All right, so now we're doing 10.5, adding and subtraction of unlike denominators. So now we have to get common denominators before we can actually start adding them. So when you look at this first problem, this one is x times x. That's what x squared is. And this is just x. So we need one more x. And in order to do that, we're going to multiply by 1, but we're going to represent that 1 by saying x over x. X divided by x is 1. So this part stayed the same. I didn't change it. Plus 6 times x over x times x, which is x squared. Now we're looking at 10.4, adding with common denominators. So I'm going to put the 6x first, plus 3 over x squared. Even if I factor out the 3, I'm not getting anywhere. So I think I'm just going to leave it like that. Now you have to be careful. This looks pretty similar, but this is an addition and this is a subtraction. So what we have to do in order to make this work is we are going to have to multiply by the opposite denominator. So for example, this side we're going to multiply by 1 and we're going to represent it as x minus 1 over x minus 1. This side we're going to multiply by x plus 1 over x plus 1. Remember, that's still 1. Anything divided by itself. So now we'll get through that kind of here. We have 3 times x minus 1 over x minus 1, x plus 1. Do not multiply those. Leave them just like that. And 5 times x plus 1. And on the bottom we have x minus 1 times x plus 1. Now we have common denominators. Slide that common denominator over. And now we're going to distribute to get rid of parentheses. And then add them together. So 3x is 3x. 3 times negative 1 is negative 3. It's a plus 5 times x and 5 times 1. So 5x plus 1. Let's clean it up and see if by any chance we get anything to come out in the end. So we have an x here and an x here. They're both positive. 3 and 5 would be a positive 8. We have a negative 3 and a positive 1. Negative 3 and positive 1, we subtract and we get 2. 3 is bigger, so it's negative. X minus 1, x plus 1. Even if I take the 2 out, I'm going to have 4x here minus 1. So I know even if I do factor that, it doesn't go anywhere. Now this problem looks a little tamer than that last one. This one is 3 and x. We need the same thing. So if I had a 3 over here and an x over here, we'd be ready to go. So I'm going to multiply this by 1, which I'm going to represent by 3 divided by 3. And I'm going to multiply this side by 1, which I represent by x over x. This one, I multiply this side by. This one, I multiply on this side. X times 2x is 2x squared. 3 times x is 3 times x plus 3 times 6, 18. 3 times x, 3x. Common denominator now. So we're just going to move the common denominator over. 2x squared plus 18. Now if I try to factor this, I can take a 2 out of both of these, but I get x squared plus 9. And although they're both squares, it's not a difference of 2 squares. So I don't think I'm going to be able to pull anything out. I think that's where I'm going to have to stop. Now all we've done is we've added subtraction. And we've added a little bit more difficulty onto the denominators. We need them to be the same. Notice that this has a 5, but this does not. Also, this one has x squared, but this only has x. If I could multiply this side by 1x, I'd get the x squared. So I think I'm going to multiply this side by just one of those x's. Could I multiply by x squared? Yes. And then on this side, all I'm missing is the 5. Watch what happens when I do that. Here, I get 4x. On the bottom, x times 5x is 5x squared. Remember, 2 bases with 2 exponents, you add the exponents. Minus, on the bottom, 5x squared. On the top, 5. Let's go ahead and continue. Common denominators. So the bottom stays the same. 4x minus 5. I can't take anything out of the top, so it doesn't even matter if I want to try to factor it, I can't. Again, be very careful. 2x plus 1, 2x minus 1. I'm going to multiply by 2x plus 1 on this side and 2x minus 1 on this side. Alright, so now, so the denominator becomes 2x minus 1, 2x plus 1, 2x minus 1, 2x plus 1. Okay. On the top, 3 times 2x minus 1, and then 2 times 2x plus 1. If we look at the top now, because the bottom is exactly the same, do not multiply it out in case we can factor something out of the top to simplify. Okay, distribute to get rid of the parentheses. 3 times 2x is 6x. 3 times negative 1 is negative 3. Minus, and I'm going to kind of put parentheses here because it is subtraction, it's not addition. Subtraction will actually cause a change. 2 times 2x, which is 4x. 2 times 1, which is 2. In order to get rid of those parentheses, we have to distribute that negative. So now we look at this and we go, okay, remember this is like negative 1. Negative 1 times 4x is negative 4x. Negative 1 times 2 is negative 2. Collect our like terms. Again, the bottom is not changing in any of this because that's our denominator. We're only working with the top. 6x and a negative x gives me 2x. So I kind of like that. But I've got negative 3 and negative 2, which gives me negative 5. I cannot simplify that anymore. Now, at first, you got to remember that when there is no denominator, we can create our denominator. We do not need to multiply this side by 1 because 1's not going to change it. But we do need this side to have the t minus 2. Oh, t minus 2, not t plus 2. All right. So now on the left side, we're going to get 6 times t minus 2 over t minus 2 minus 1 over t minus 2. And they have the same denominator now. So t minus 2 on the bottom. Here I distribute the 6. 6t minus 12 minus 1. Clean that mess up. There's only one t on the top. Here is a negative 12 and a negative 1. That's negative 13 over t minus 2. I can't factor anything out. I'm done right there. Now we have another addition problem to practice. Again, different, so I need to look at it carefully. And I say, okay, with this, all I can do is x minus 2 over x minus 2, which equals 1. I can multiply anything times the number 1, no matter what. So if I disguise it as a different number, but it's still 1, it still works. All right. Here we have x times x plus 2 over x plus 2, x minus 2, plus 4 times x minus 2 over x plus 2 and x minus 2. They have a common denominator, so I can just add them together now. Distribute. So x times x is x squared plus 2 times x. Over here, distribute. Plus, so it doesn't matter, there's no reason to worry about parentheses or anything else. That plus isn't going to change it. 4x minus 8. Clean that up. X squared. But here are two x's. Positive 2 and positive 4 gives me positive 6x minus 8. The bottom is x plus 2, x minus 2. Now I have a question of whether or not I can factor the top and get what I need for the bottom. And I'm going to try it because I want to see, does it factor? Not a lot of room to fit this box in, but that's okay. We don't need a lot of room. X squared, negative 8. Now, if I'm looking at, I got to get a positive 6 in the middle. I was thinking 4 and 2, and to be negative 8, it would have to be a negative 4 or a negative 2. But if I add those together, I'm not going to get a positive 6 in the middle. If I want negative 8, I could also do negative 8 times 1, or 8 times negative 1. But again, I'm not going to get the 6. And since I can't seem to figure out a way to factor this top, it must be that that's my answer.